My name is Ewan Fairweather. I'm a program manager in the Azure Customer Advisory team.
And I'm Tobias Ternström, and I'm program manager in the SQL Server Options, so Windows, Azure, and SQLDB. And your microphone. That's all Ewan's fault.
Yes.
There we go. Yeah, I'm still Tobias. Okay.
Cool. The group we work for, I work for, is part of the cloud and enterprise group within Microsoft. We used to just focus on SQL, and now we really focus across the entire on-premise and also Azure platform, and really look at how we can help take customers on a journey using that technology and make sure that we go and find out what the white spaces are on the edge space of that area. So find the most challenging scenarios and then bring it back to people like Tobias and other people across the other groups. And what we really want to talk to you about today is one of the kind of new episodes we have within this journey that we're on in Azure. This is the Premium DB offering that we have. So what we will do is we'll start off with some kind of level set in terms of context on the persistent data options that we have within Azure and the kind of general application journey that we've seen over the last couple of years with our internal large partners. And we have some really big workloads now which are running on top of the Azure platform generally and also on top of Azure SQLDB specifically. And we'll talk to you about the different kind of stages that we see in the different aspects of their workload and how they use, in a general sense, those different technologies that are available. And then we're really going to focus on the Azure SQLDB Premium offering and give you guys an idea of exactly what it is, how you can use it, and why you should use it in what specific scenarios. Later on this morning, we also have 2 more cloud sessions. Immediately after this, Alexei, who's in my team as well, is presenting on data warehousing in the cloud using virtual machines. And for those of you that want to see me and Tobias again, you can see us in the 3rd session today talking about how to optimize an application.
Yeah. So how many of you have used Windows, some part of Windows Azure? Okay, so maybe 1/3.
Okay.
And how many of you did use SQL database? Okay, so okay, cool. Thank you.
Cool. So let's talk about the application journey then. Almost every customer that we see working with on the Azure goes through these kind of 3 steps. The first one is kind of, we want to get some functionality and scale, and we want to actually run our application on the cloud platform. It may be a new application, or it may be a migration of an existing application that they want to move into the cloud. And they may decide to move the SQL application into the cloud for any number of reasons. A common one recently that we're finding is if people require lots of storage for their application, media scenarios, streaming scenarios, if they have a SQL database, the driver for moving into the cloud may be something other than SQL Server. For instance, if you have a lot of media requirements, storage, the COGS, the cost that Azure Storage provides, and the GODR is a very compelling feature. Then they go through this period of really, we've provided the functionality in the scale, and they basically figure out how we're actually going to run this system at that level of scale. And then really the driver comes, how can we take advantage of the cloud platform and drive down some of the costs that we have? Because the great benefit of the cloud is that it has elasticity at all the layers. You can add more databases, you can add more compute, web and worker roles. And often when you're on that kind of journey on the way up, you will add more than you need because it's a necessary part of growth. And then typically you will reduce that.
So it's somewhat interesting to compare this to kind of traditional development, kind of pre-cloud era, right? So first of all, the functionality and scale is new, right? Traditionally, you develop for functionality first, right? You want your app to work, and then you can go and optimize and so on. But because of the fact that you have smaller units of scale in the cloud, you need to go and design your app for scale earlier than you do it traditionally. And the other thing is cost, which is something that developers traditionally don't worry about, because someone bought the server, a couple of servers, and then it's all sunk cost and you just run on that. But the whole premise of cloud is really to bring down the cost of operations, cost of running your applications. So I meet a lot of CIOs and so on when we do briefings with them over in Redmond, and it's interesting to go ask them, do you know how much you spend on IT? And they typically know how much they spend with us, so how much they pay Microsoft. They know how much they pay SAP and a couple of these big ones. And then they have hundreds of other applications that they spend a huge amount of money on, and they don't really know how much they spend on each of these applications. And that's something that all of these guys are very interested in changing once you go to cloud, right? So you can see, does this app, is it running efficiently? Is this app worth paying 100,000 US a month, or should it be something different? And that's something that's changing the way we think very much when we do software development today.
So when we look at the general storage options that we have, there are essentially three main buckets. For relational database, there is the platform as a service, Azure SQLDB offering, which is the fully managed service that we provide for you, which is a PaaS service. And basically, you create a database, and we take care of all of the availability, all of the movement and placement of you within the clusters. We buy new clusters behind the scenes. Tobias runs the kind of performance KPI team, and they are looking every day at how faster any individual database is performing, where do we need to add more capacity, remove capacity, all of these type of things. So it's very much, I want Microsoft to provide control, for that, and I just want to run my database, and I want to use my database. The next option is the SQL Server in Infrastructure as a Service, or more commonly known as virtual machines. And this is where you get the dedicated virtualized compute and memory, and you can install SQL Server or use one of our gallery images, or you can indeed install any other database or even any other operating system that you have the bits for, right? But it's really up to you to go and provide the control for that. So the best example is if you want availability within Azure, you have to define this thing called an availability set, because any one machine, we can actually take and provide some patching to that. So we don't provide an availability SLA by a machine by itself. You have to group at least two machines together and define an availability set, and then we will guarantee you that we will only take one of those down, and we give you a guarantee associated with that. What that effectively means is if you are deploying SQL Server within virtual machines, you have to use one of our HA technologies, and the options you have are either database mirroring or availability groups. So you have to go through and do those things as well, and you need to be cognizant of that. The Azure SQLDB service is taking care of that. But you do get more control, and you also get some additional surface area for things which we haven't currently lit up in the PaaS offering. And then on the kind of NoSQL front, there is the Azure storage, and there are various different primitives that we provide for that. There are tables for the kind of key value store, there are blobs, and there are also queues as well. This is no relational, this is Erasure-based cheap storage, which is really optimized for density and scale out. And there are actually some fairly interesting scenarios where you can actually use this. And what we're giving you effectively with all of these offerings is the choice to really look at your application and think what makes most sense to store where. In a lot of on-premise applications, we had this big SQL server, and we could put all different types of data within there. Within the cloud, you can actually choose based on what your input requirements are and also what your output requirements are.
Yeah, there is also, so I often get this question on SharePoint. So how many in here use SharePoint? Ah, very good. So SharePoint uses SQL Server quite extensively, right? And many people ask, so why couldn't you use it more efficiently, right? Why couldn't SharePoint use some other techniques for certain things? A common thing that comes to mind is blobs. So all documents in SharePoint are stored in SQL Server. And depending on your scale, it could be better performance-wise, for example, to store them somewhere else. The problem really, when you design software that someone is going to install, is this whole install and maintenance part of this. So if you design SharePoint for on-premise for installation and you used kind of the perfect storage for everything, you may need, let's say, 5-10 servers to just run a single, simplest possible SharePoint installation, which just would not be really doable from an administration point of view. It's already a lot of things that you need to manage, but it would be a hugely different thing. Whereas in the cloud, you don't have to think about this. You use managed services instead. So in the cloud, you're much more interested in what is the perfect tool for the choice. I will use this NoSQL Notion for something, I use the relational database for something, and I'll use whatever else for something else. So it's very important that you don't try to shoehorn things into the box kind of where it doesn't fit, because that's not really going to work in a cloud type of environment. So that's something that also changes quite a bit when you go to the cloud. So I often say that we sell hammers in Building 35, so in SQL Server, and we build the absolute best hammers in the world, right? But if you're going to cut down a tree, you can do it with our hammer, right? But it's going to take a while. So you may want to go and buy a saw or something like that instead. So that's very much something you have to think about.
So effectively what we have then is that there are 3 different ways that we can run SQL Server. And there's really, the 2 kind of pivots to that are really the amount of dedicated resources that we have and the kind of friction in terms of control. So whether I have a high control or a low control. So traditional SQL Server, raw iron, is a scale-up approach primarily. We've added lots and lots of support for additional CPU cores over the years, and you can go buy the big box and it works great. I myself, the last job I did in Redmond was running the SQL Cat Performance Lab, and every week we worked with a different customer who wanted X number of CPU cores and we needed to scale their app. And there are absolutely scenarios, and most of you probably work with the box product where that makes sense, and it will continue to make sense. However, there are other options, and we want to make sure you're aware of those. So SQL Server in IaaS is kind of, the way to think about that is I have dedicated CPU and memory, effectively. Yes, it's virtualized, but it's dedicated to me. And I have a shared storage. Shared, as commodity storage, essentially, that I'm connecting to. So you can take advantage of this in a lot of ways. Any kind of trade-off that you can make to trade CPU time for I/O time is going to be a good trade-off in this scenario. And we see a lot of people who want to do kind of light data warehousing workloads, who want to be in that spot, and they will go and deploy with the IaaS offering. And really, the next level that we have is really the Azure SQL database. And the resources that we have there for the shared offering are really, they are shared. We have, tens or hundreds of databases on the same nodes. The clusters are hundreds of machines in size. And whilst we've done a lot of work to reduce the variance in terms of performance that you get, you are paying $5 per month per gigabyte for that database. So effectively, there is some trade-off.
From $5.
From $5, yeah. So what we've really done then is really, with the premium offering, is really provide you the ability to have all the advantages of the managed platform as a service, and really move up that spectrum in terms of the dedicated resources that make sense. And the most common question I get when we talk about this is, why should I bother with that if I'm paying for dedicated resources when I could use a VM or I can use my own box? And the great thing with this is we actually provide the mechanism for you to move from the standard through the different t-shirt sizes that we have and move back again. So for a lot of premium OLTP applications, there is some elasticity in their workload, so they will have a given day, end of the month is 10 times the traffic, or one of the systems that we worked in the UK recently was the UCAS system. This is the University College Admission System. On middle of August, basically every high school student in the UK logs onto this site at 9 o'clock in the morning because they get their results. And this year, they used the Azure platform to provide that. And under the covers, they used SQL database. That system has exponentially more usage on that day than it does the rest of the day, because once you've got your results, you really don't mind, right? So that is a good example of where the premium DB is a really great fit.
Yeah, so the big difference here is really that here you have a declarative model. Here you tell us, I would like blah to happen, and then the service goes and gives that to you, right? Whereas in the other two places, you go and make it happen, right? You go and design and you set up your availability, all of those things. And it's important, once you go further to this corner, right, there are some things that we don't support yet. So for example, we give you HA, right? It comes with HA built in. So we always have a minimum of 3 replicas of your database in 3 different fault zones in our data center, right? And you can't turn that off, or at least not yet, right? We don't have that functionality. So meaning, if you're going to build a data warehouse, right, everything is fully logged, everything is fully replicated to all of these other replicas, it's probably not going to be the best option, right? So you have to think about, when it comes to this managed service, what does it offer you, right? It comes with a bunch of choices, and a bunch of choices might not be there yet, such as, hey, I don't care if my RPO is 1 hour, I don't care. If I lose an hour of data, don't mind. Just make it fast, right? And maybe bring down the cost. That's something that you can't choose yet, versus you could do in a VM, right? You could go and say, no, don't mind if the VMs drops out a bit. Let's not do HA, let's do backup once a day, because I run some sort of data warehouse workload, or whatever it is. So that's an important distinction to make. When you look at the services, you have to look at what they offer and see what works for you. Okay?
So often there are these decision points that you can take, like Tobias has alluded to. So the common types of data that we see going to Azure storage tends to be minimal relational and point lookups, and primarily append workloads. So if you have an audit table and you don't need to do relational queries on top of it, you just need to do point lookups, that may be a good candidate to consider storing in Windows Azure table storage. Telemetry logs, is another one. Things where there's lots and lots of cold data and you just need to keep it around. Storing it in Windows Azure storage is a good option for you. It's protected, it's relatively cheap, and you're not paying for stuff that you don't need, essentially. The common things that we see going to SQL Server in a VM are where really people want that full control and they want to make those trade-offs that Tobias has just talked about. And the primary case right now is either where there is some kind of compatibility with an OLTP application that is, that is too much effort for them to refactor and they want to just move that. That is one option. Or the kind of light data warehousing workloads. And the other option then is really SQLDB, and people who move to this are really people who don't want to manage their databases in the same way anymore. They still need to maintain some operational control over the databases, but they're not going and clicking and taking backups and rebuilding stats and all of those things. And really, Premium DB is what we're going to talk about, and that extends these capabilities.
Yeah, it's also... So if you look at all of the applications that you have in your organization, you're going to have a handful at most that are these super critical apps that if they go down, your company could go out of business. And those typically make sense to have a staff managing and all of these things. But then you have typically a huge amount of other applications where the cost of managing them just doesn't really make sense. So the big thing that we do in SQL database for you is obviously give this HA and so on. But if you think about, if you wanted to, what's the fancy word for putting stuff together?
Consolidate.
Aha, that one. So if you want to do that one, it's a big, so first it's where do I place all of my stuff and how many things do I need to put my stuff on, right? But then you get into okay, I'm going to place a new database. Then you have to think about where do I place it, right? And once you place it, you have to kind of look at the server and say, hey, this one is getting hot. Maybe I should move something off it, and then you have to start thinking about, well, okay, where should I move it, and based on what, and should I buy a new server, and all of these things, right? That's really what SQL database does for you, right? It does all of this placement, load balancing, and all that you see really is a database. So the only thing that you tell the system is give me a database, or I don't want my database anymore. And then it takes care of all of those things for you.
Cool. So really what we'll talk about is some of the typical performance factors. And these factors affect any distributed system. And we just need to be more explicit about them in a cloud distributed environment, right? The way the system is designed is effectively we have separate clusters for Azure Compute and separate clusters for Azure SQLDB. And that there's good reasons behind that. And what that effectively means is you're going to go through a software and hardware network stack from any compute calls that you make to any Azure SQL database. And at this point, you also go through a gateway machine as well. And the gateway machine's job is really to say, any call, any login that you want to do to an Azure SQL DB, we route you to one of the 100 machines, and we give you to the one that actually has your primary copy right now. So we maintain all of that knowledge, and we route you through. Once you've established that connection, you then can route all the way through to that, as long as it doesn't time out. You know, that's a much less expensive. So really the first two things to be aware of is the latency. There is some, you know, you have much less control in some ways, or you have much more flexibility about some things, specific the elasticity, but you have much less control of the latency. In an on-premise environment, when we did SQL Cat Labs, we would always be, you know, making the minimal path and making sure we just had one switch which the application server's connected to, and then dedicated paths for front-end connectivity and back-end connectivity and all of these things. You are going over a common network here, and there is some, you know, distance within that. So being mindful of that in your application design is something we'll talk about in the next session later on. The other thing is establishing connections. The cost of going through that gateway box and establishing the connection is significantly more than when you already have one established. So using connection pooling with whatever data access layer technology that you're using will give you significant benefits. And the last thing is really the multi-tenancy, right? We've designed this to give you this flexibility. We have to provide some multi-tenancy within the shared pool in order to provide it at that price point. And that has been one of the sticking points for some class of workloads. And this is really where the Premium DB offering helps, and which is basically where we are providing some dedicated resources. So when you look at the kind of web and business additions, over time, the value for your money that you get changes slightly, because we have lots of resource controls within the platform, but essentially it's still a multi-tenant system. So there is some variance in the performance that you get over time. And as Tobias says, there is a load balancer that moves people around, and an algorithm and all of these things. And it's, you know, there's also like a daily report, a weekly report. There are lots of reports that go out that tell us how the service is actually doing, and we know when it's going good and how to make it better. But there's still some variance within there. And that shows up in a couple of ways, right? Within your application, if you try and do too much, we will essentially provide a seatbelt. And the seatbelt is there to protect you, and it's also there to protect other people who are on the box, right? And this is what's called resource management or throttling within Azure SQL DB. And there are essentially two types of throttling that we have. The soft throttling is where we say, you yourself are being too busy on this node, and we're going to kill all of your connections to that box. And the reason we do that is we want to stop you being the noisy neighbor. And then the other one that we have is a hard throttling, and we really want to avoid this scenario as much as possible. The hard throttling is where we kill all of the connections on the box, because we view that we're at risk of losing that node or going past one of our critical thresholds. So over time, obviously hard throttling impacts many tenants, many customers on the platform. It's all the people who are on that box, whereas soft throttling only affects you. And what we have done over time is really provide some move more towards a soft throttling. So we want to actually, to the people who are doing more than they effectively should be doing, we will basically, cut them out early before they affect everybody else, right? It's like removing the busy guy from the party, kind of. And the most common example that people will see is around the worker thread governance. A limit was placed over a year ago now, which basically says if you have more than 180 worker threads, so it's not sessions, it's worker threads that you have, so 180 things in sys.dm exec requests, there's probably some problem. And we did a bunch of analysis, and basically in that scenario there's typically some lock or latch or application bottleneck, which means that we are basically having a convoy effect. And what we found is that anyone who went up to 180 worker threads almost always continued to have this kind of convoy effect and would always go to 500. So for that reason, what we do is we actually cut people off at 180 within the shared pool, and they then have to re-establish those connections, and that protects the rest of the tenants on that box. But in certain scenarios, that's a maximum guarantee that you have. There is no minimum, so you can get cut off some point below that. It doesn't happen as often, but you can get cut off at, say, 150 if there are just too many other people doing things on that box. And really that's where the premium database actually comes in. Really for those classes of application where you're very kind of latency and performance sensitive, and you really want to pay for an additional level of service and some dedicated resources in order to support that. And these are the same trade-offs that you're making on-premise, right? As Tobias said, there is always, when you go visit a customer, there is this mission-critical system that everyone runs about, and there is this database which is on its own node and all of those things. And then there is the consolidation environment, and that's really, you're making that choice there effectively within your organization. And what we're giving you here is in a declarative model, the option to kind of define and declare what you would like, and you can also do that at a period of time. You don't need to go buy the box and keep it forever. You can just choose to use it at a certain point.
You can think of it as that you can attach your database to different types of machines, right?
Yeah.
So you just tell us, I would like mine to be faster for a while, and then the system takes care of that and moves you to that type of node.
So basically, in order to give you those reserved resources and that predictability, it's important to understand what that means under the covers, right? We effectively have, we do have reserved resources using resource governance across all of the free nodes. And the reason we do that is because your primary guy is important, but especially when you're doing a kind of insert-heavy workload, in some cases, the secondary can actually cause a bottleneck. And this is the same in on-premise today. If you have database mirroring or availability groups, and you had a SSD drive in your primary guy, and you have a really slow drive in the other guy, and you have synchronous replication enabled, synchronous mirroring, or availability group replica enabled, the slower disk can be the bottleneck, right? So in order to protect you against that scenario, we reserve resources on all of the free nodes at the level of CPU, memory, and I/O that you have effectively chosen at that point in time. And when you move, we move you from on all of those free nodes. And the movement process is mostly an online process. So basically, we will go and seed the data on wherever there is capacity within our isolated pool for you, and the database will remain online apart from a kind of 30-second window where we will move you across. So this allows you to, like Tobias said, allows you to go through and choose. You may want a kind of web and business Monday to Tuesday, and then at the end of the month you need a P2, and then you can bring it down to a P1.
Yeah, and it's also, there's a huge difference here in terms of what you get, what you pay for. So in the more stochastic web and business edition, that's an overbooked place, right? So we basically sell more seats than we have. It's just like an airline, right? And why do we do that? Well, it's to bring utilization up, right? So traditional data center, is good. It's typically very good if you get 10% utilization, right? So you spend 1 million crowns and you get to use 100,000, right? So you basically buy for peak load, or the standard thing of an application needs a server, and then you buy another server and you add it to your data center. So it gets extremely expensive to run things this way, right? And that's really what cloud comes from is, hey, let's see if we can get utilization up, right, above 10%, maybe get it to something like 50, right? So because of that, for example, if I have 10 databases on one machine, I'll have 10 other databases on the secondary, right? And I'll do active mirroring between these replicas. Whereas in the isolated pool where you buy a premium database, I'll have a database on the primary and I won't have another database on the secondary, right? So P1 is the smaller one, so we have X P1s on a primary, and those we just have the secondaries with no active primaries, if you will, on those. Up to the largest one, and the largest one we may only have one on a machine. So if you buy the largest one, you're really running on 3 to 4 machines, just your one database, right? So that's where you start moving away from this, hey, I'm going to cloud to squeeze down cost, right? They're saying instead, well, I want these dedicated resources. And that's where apps have to be smarter, right? So if the app can try to say, well, now, like Ewan alluded to, now I actually need these resources available to me and go and upgrade, right? And just, you run an API just and say, hey, give me more. So that's the nice thing, right? It's nothing else you have to do. Just call an API, give me more, and then you move up. You run there for a while and you pay for that, and then you say, no, I'm fine now, and then you move down again, right? So that's a huge difference from kind of traditional computing. And that's also, if you wanted to do the same in VMs, you have to do all of that maintenance work to figure out where should I move it, do the actual move, and so on. Whereas here, you just say, hey, give me more resources, and then all of this moving goes on underneath the covers and still keeping with the availability SLA.
So really what we see some common customer attributes where they want to move to Premium Edition. And what we're going to, in terms of the learnings for Premium Edition was announced in preview a few months ago, but we've actually been running this in a private preview for over 12 months now. So these learnings are based on kind of experience over that kind of 12-month period. And what we see is there are people who have kind of high throughput requirements, and typically that's coupled also with a kind of low latency and specifically a low variance in the latency. So EasyJet is an example that we've referenced before. EasyJet have this feature which is called bums on selected seats. It's effectively where you can opt to pay an extra amount of money and you can choose a particular seat and you can reserve that seat ahead of time. And basically, that system, the back end, runs on top of Azure SQLDB. And for their January flight sale, they have lots more traffic than they do the rest of the year because they incentivize their customers with discounts. And basically, we ran that this year, so January 2013, on top of a premium database. And as some of the figures that I'll show you later show, that was really, as they had this spike in throughput, they wanted to either maintain or improve the latency in terms of the response time. So basically, what does that actually mean under the covers? So the Premium Edition is really giving you very defined guarantees across a number of things. So basically, if you look here, for the kind of P1 and P2, they are the offerings that we've released publicly for public preview. There is also 2 other t-shirt sizes, a P3 and a P4, which we use a kind of engineering discretion when someone has already capped the limit of a P2. And basically, we'll give you a dedicated CPU core, a certain number of worker threads, a certain number of connections that you can have, and then some dedicated memory and some dedicated I/O. And we give you that across all of those machines. And basically the price there is, at the moment, it's $930 for a P1, and that's billed on a daily basis.
Well, right now it's half of that.
Half of that, yeah. So at GA, it will be $930. Right now in the preview mode, as with all preview as Azure technology, you get it at half of the cost. And the billing increment is done on a daily basis. So if you have some elasticity in your workload and a few days at the end of the month, you can move for a couple of days and then move back. So how do I actually go and do that, right? So these are some screenshots from the Azure Portal that I took the other day. Effectively, we create our server. So I've made this server here in Southeast Asia, and you can go through the Azure Portal and request the Azure SQLDB Premium preview program, and basically you will be told that yes, I've been granted some quota. And what that effectively gives you is it gives you the ability to have this scale tab, and you can basically, for the number of reservation quotas that we have granted you, you can choose to move that existing database from your standard database to a P1 or a P2, right? And the way that you can do that is you can either do that through the portal or you can do that through PowerShell. Anyone who is managing Azure machines will know that PowerShell is the kind of tool of choice, and you just become in love with PowerShell once you start using Azure, because it enables so many scenarios, it enables you to automate so many things from an operational perspective. So in this, fairly simply, you can basically define the connection object that connects you to the specific server and the database, and then you can define the new service level objective that you're going to have, and we will basically move you. When we move you, basically, you can check on the status of that. As I mentioned, it's an online operation. Basically, the exact amount of time that it takes in order to move you from your current shared pool to some isolated nodes that we have, like Tobias says, which are kind of stacked at the appropriate levels. It really depends on the amount of data that you have, right? Obviously, it's going to take longer to move a 150 gigabyte database than it is going to be to move a database at a gigabyte or less. But while we're in that process, it is an online operation, so it's only during the final source drain phase where we effectively kill all connections while still maintaining our availability SLA and fail you over, that you will effectively see any changes. And when we do that, typically the kind of failover time is 30 seconds or less. So it can be 10 seconds, but 30 seconds is a good benchmark. So well within most acceptable response times. So we also provide the ability within the master database to basically query the current service level objective that you have. And you can see here I've got Ewan's Premium, which is currently on SL as shared, and the target is a reserved P1, and the status of that is pending. So we give you the kind of options to basically check that and see how long that kind of operational move time has taken. And basically in this case, this one here, we started at 1732, moving this premium this database from the shared pool to premium, and it took about 15 minutes. And that's for a mostly empty database. If you have a 150 gigabyte database, it can take up to 2 days right now. And obviously that time will come down, but you do need to be aware that there is some kind of seeding time just for us to move it and basically fail you over. Yes? Is
it possible to control when the failover occurs?
No.
No, it's not. So you can start the process, but it's non-deterministic when the failover. So go for it.
It's possible. You can't do it.
Yeah. So, but this is where the difference is within cloud, right? Within the kind of box world, we're used to this kind of pit stop Formula One style maintenance, right? I can come in, I can do my maintenance really quick, and then I can move. What we're doing in the cloud world is really saying, we will give you this availability, SLA, and we will always aspire to fail over within 30 seconds. And basically, we will give you 99.9% availability, and basically we will do that within those guarantees. So and those things happen all the time anyway for big cloud applications, right? We are continuously, in order to do that load balancing and move people around and all of those things, we have to basically move some databases from one node, to another, and effectively it's the same process, which is doing
we're
that.
working on adding, so you can imagine how lots of customers have feedback on, I would like to control this particular part of the operation. So that's something that we know about and are adding features to various parts of the system to handle these kinds of things. So that sounds like a reasonable thing, right? That you would want to say, well, please, move me, but just please don't do it right this particular time, right? But generally, you want to build your app so that it doesn't really matter if the database is out for up to, 30 seconds or so.
So the next kind of question then is, should I go with premium database or should I go with a larger VM? And really, we've gone through this with a number of customers. Customers who run a lot of Azure SQL databases will often come to us and say, when the virtual machine's offering, can't I go do that consolidation myself? And sure, you can, right? You have that control, and if that makes sense for you, you should do that. But there are some factors to consider. First of all is one VM cost against a P1 size is not really representative of what you're fully getting, right? When you pay for a P1 instance and you get 150 IOs and one CPU core, what you're actually getting is free copies in a highly available system where we manage all of those things for you. So really it's important to think about what is the actual cost. If I want automated failover, I'm going to need to deploy within Azure an availability group, which is sat on top of a cluster, and I'm going to most likely use the node majority and file share quorum model. So that means that I'm going to have at least 2 VMs, and I'm also going to have a file share witness as well. So there is some cost in doing that before you enable, look at all of the kind of management cost and all of those things. So what we'll talk about now is really sizing and capacity planning. So that gives you an idea of what premium is. We'll now look at how do I actually size and determine what capacity that I need. And this is very much an ongoing process in the cloud. And the reason why it's ongoing is because we can actually do something about it. Sizing and capacity in the on-premise paradigm tends to be something that you do on a monthly or yearly basis. We would come and we'll run a lab and we'll look at the kind of performance and throughput that we need for some number of years out, typically 3, and we will build our system and size it for those things. As Tobias has mentioned, in the cloud, we can actually change those kind of t-shirt sizes on a kind of daily, monthly, basis that we have based on our workload requirements. And that's the key way that you can actually drive down the cost within the cloud, which is in that third phase that we talked about in the beginning, which is where your application becomes smarter, where it figures out actually, hey, I need to reduce the number of compute instances, I need to increase and then decrease my Azure SQL database. And basically what you'll see us light up more scenarios here that make it easier for you to get that level of insight. So basically the kind of approach that we take then is really when we're sizing databases is to look at the kind of large resource consumers and kind of measure that peak load over time. And with our internal large customers who run on Azure SQLDB, we will meet them on a kind of weekly basis, and we will look at what's their CPU and I/O distribution over a weekly basis. And the first kind of things that we'll do is really to look at how we can kind of smooth out on a weekly basis that graph. We want to avoid having massive peaks. So you can do certain things, right? You can tune your workload during the day, and I'm sure many of you do that already now, and it's basically the same in SQL Azure as it is in the on-premise world. And then we can do things that, again, are similar to what you do in an on-premise world. We can move the weekly maintenance to a weekend when there's no users really on the system. We will move our kind of daily maintenance, export jobs, for instance, we'll move them to a kind of out-of-hours period. And really, we're working on kind of smoothing out that consumption profile over the kind of weekly basis. And we provide a number of DMVs that now allow you to see that, and you can see the kind of standard performance ones, which are you should familiar with in the box product, and then we also provide the standard data access and usage ones to look at missing indexes and all of those things, and then we provide a kind of few additional ones, which is this resource usage and the health ones, which are really lit up in a way that's specific to Azure SQL DB. Often we get the question, why don't we have X DMV in Azure SQL DB? And what we really want to do when we light up those scenarios is think about what makes sense to talk about and measure in a cloud environment. So, for instance, we have the event log, which really measures, it gives you the same kind of information as you get in the SQL Server error log on-premise. And we also have the connection stats, which is useful for basically monitoring how many connections I've had over a rolling time window, how many succeeded and how many failed. And then the one that we've added recently is the sys.resource usage and sys.resource stats. And basically what this gives you is it gives you a fairly easy way to look at, on a kind of rolling 5-minute time window, how many CPU cores, how many IOs am I actually doing? So it gives you that equivalent of a kind of CPU counter and IO counter in Perfmon, right? You can very quickly go, run a query, and basically understand over the last 7 days where my kind of peaks and troughs were, and you can bring this into Excel, and you can kind of do a chart and do all of those things.
The preview thing is is somewhat important. So this view may change over time. It's part of the preview of Premium. So we don't guarantee that this view will look the same as we go. There's also kind of two things missing in the view, if you will. So one is we only show you the average for the 5-minute interval. And averages are sketchy things, right? So, you may have had a huge peak for 1 minute and then no activity, so your average doesn't look all that high. So that's one thing that's just missing. You obviously want to have kind of the max and maybe it's standard deviation or something like that. And the other thing is you don't see any data around the log use. So kind of the rate of change as you write to the log. These are all IOPS related to data files. So reading from the data files and writing when we do checkpointing and lazy writer writes. So that's just two things to be aware of if you start testing this out.
So what we've provided on these slides is really some queries that you can run to really look over a period of time at the kind of average and max resource usage and the kind of percentage of time that you're using more than one core. And as Tobias said, this is not 100% accurate. The purpose of using this is to get this kind of ballpark. What size database will I actually need for my workload? If my number of users double, I'm going to be more than one core. 2% of the time, I'm going to be an average of 0.97, and you can start to make those things in size based on, hey, I need a P1 or I need a P2, right? And it's enough to get you to make that decision. So then, basically, in terms of managing this database resource growth, we talked about those kind of 3 phases at the beginning in terms of the application journey: the performance and scale. Functionality and scale, the kind of operational excellence in terms of running the system, getting some insight into what is happening, understanding how I can correlate application errors with my database errors, and timeouts and those things, and then really driving the cost down. And what we're giving you here is we're giving you more dials that you can turn, right? So you can say, for this database, I want to move to a P1 and a P2, and then I want to move back down. But it's important to mention that that's not the only option that you have, right? You can either kind of scale out your data model, if you like, or you can actually do some tuning to increase the density for a given size that you have and effectively pack more users within that container. So there's really kind of 2 paths that you can take to improve your cloud service. The first one is kind of spend more money and purchase more capacity. And if you just have a peak for a couple of days per month or day per year, that may make sense, right? or you can kind of optimize and tune, and obviously you can do a kind of combination of both of these. And we really see people do this kind of hybrid approach much more often, within the cloud. They will come, one of our customers is running a P4 a couple of months ago, and by doing some fairly rudimentary query tuning, basically reducing the number of indexes that they had on one of their main OLTP tables, that reduced the number of writes that they were doing for their Azure SQLDB. So that meant that they could reduce from a P4 down to a P2. So you can often kind of balance these approaches and figure out where the kind of sweet spot from a technical and business model perspective is.
And this is really a paradigm shift, right? Just to be clear. Like, in the last, 10 years or so, it's been a huge thing, the whole thing with just make coding simpler, right? Because the big cost that you looked at for applications was mostly development time, right? So like things like Hibernate, Entity Framework, Scooby-Doo and his friends, like lots of these things, right? And how many have used one of those? Okay, most of you, right? So you develop your app that becomes, I'm not sure if easier, faster, right? And then you start looking at the resources the app consumes from the database and other parts, and you typically find that this is pretty high, right? But since you buy one server per app, it doesn't really matter. All of a sudden, people will know how much it costs to run a certain app, right? So all of a sudden, it's going to be much more important to actually write efficient apps. So I'm not saying that you would never use and hibernate in these things, right? But you have to start evaluating where it makes sense and where it doesn't make sense, where it's cost effective and not. Because this sounds a bit odd, right? But it's not environmentally friendly, right, to use Hibernate, if you will, right? Just because you use more resources. So using more resources means someone has to, run their nuclear power plant harder, or, burn more coal or things like that. If you can be more efficient, if you write more efficient apps, you need less power to run the data centers and all of this. So this is actually a way bigger shift than most people typically think of. So that's important to start kind of internalizing, and that means the way you do development changes.
Yeah, and just to give you an idea of what that kind of cost can typically be, I have two customers at the moment I'm working with. One is moving a large media application into Azure, and we did some tuning on their application tier, so not SQL, but we basically looked at their application tier and their caching strategy, and by moving them from a distributed cache to a local cache and removing that context, the network overhead and the serialization overhead, we were able to improve their density on a given application node by 10x. So they can now run their compute 10x cheaper with 10 times more users on a given web server. I have another customer who was using Entity Framework that basically came to us because they had unpredictable performance in Azure SQLDB. And we obviously want to investigate that and understand, is that something that is a problem with our platform, or they're just using too much in the application. And they actually had an Entity Framework statement which was basically writing to a very large temporary table when it didn't really need to do. The Entity Framework generated that. And that was basically generating 90% of the CPU and read overhead on the system. And they got away with it most of the time because we don't replicate those temp DB writes to the other nodes in the system. So we have much more CPU and memory within the shared pool than we do kind of I/O. I/O is the kind of most expensive and most protected resource that we have in essence. And basically by tuning that one statement that was used, it was one of their main selects, we were basically able to reduce their consumption by 90% as well. So these benefits are significant that you can get.
Yeah, I am more or less the collection agency or tax authority of Microsoft, if you will, because we obviously have a huge amount of internal services that run on top of SQL Azure, such as Office 365, diagnostics of the whole Exchange service runs on top of SQLDB. So we sit and look at, so obviously they're consuming within Microsoft, so you can imagine how some people think, well, that's, funny money, right? They're just buying from ourselves, right? But we sit and look, hey, this is what you guys are using, and we go and tell them, guys, this is just doesn't work out. You have to make your app way smarter so that you don't go and spend all of these company resources, and in the end, all of these environmental resources to run your app just because you didn't spend the time to optimize, right? So that's basically the exact same thing as if you buy a bunch of servers and just, I have my servers and they just run and they take care of this workload for me. Once you can look at exactly what's being used, and once someone bills you for it, you have a whole different mind, you have a whole different thinking around how to build your app. So this is something that's a really, really big thing that's definitely happening.
So we'll talk about some the kind of customer learning. So data access in the cloud is one of the key areas to optimize your application. There are two key areas of attention to look at. The connection management issues is the first one. There's kind of less reliable connection state because you have a longer path between your app server and your Azure SQLDB. So you need to provide, and also we kind of fail over at certain points when we need to move certain machines. So as Tobias said, you need to have that kind of 30-second window in your application where you can retry and have that retry semantics. And there's some links that I've provided at the end of this slide deck which basically link to a cloud, some guidance that we produced, which was a code delivery called Cloud Service Fundamentals. And what Cloud Service Fundamentals does is it takes all of the learnings that we've had over the last kind of year to 18 months, building out some big systems across hundreds of scale-out Azure SQLDBs, and we provide you with a working implementation of that provides you with a scale-out mechanism and also the full kind of data access layer and the telemetry framework as well that allows you to do the correlation. So we'll talk more about this in our 11:45 session, but if you really want to get your hands dirty with it, downloading that is the best way to go. And
you learn, it's super interesting to get really deep into this telemetry and then start building data warehouses or Hadoop or whatnot over this data to look at it, because all of a sudden you start understanding so many things about your app that you just had no idea of. So that's a really also a big shift. The way you look at telemetry now is very different from what you traditionally do. Traditionally, it's very focused on security, for example. Did someone break in, or what happened yesterday for some reason? Now it's much more, why is the app running like this? How can I make it more efficient? How can I push the amount of resources down? Because the easiest thing as a developer or as anyone is just to buy whatever the max premium gazillion, right? And just run there and everything will be perfect. Right?
The next area really is then the latency between the app tier and the database. I don't want you to get the idea that it's kind of seconds. It's not, but it's not going to be sub-millisecond. You're going to get the kind of millisecond kind of...
You move from microseconds to milliseconds.
Yeah, effectively. So, but if you have a very chatty application that was assuming you had microseconds, that's going to have some impact. So one of the first things that you can do is kind of batch your inserts. And we provide this framework in the Cloud Service Fundamentals. So the most common technique is to say, I'm going to define in my data access layer a buffer, and that buffer is going to be a time t or size n in terms of rows. And this does mean that you can lose t seconds of data or n rows of data. Say if you set the time window size to 5 seconds and the row size to 10, you can lose 10 rows or 5 seconds maximum. But in terms of the testing, this is some testing that we did earlier this year. Basically, this is running for a minute with doing 10 inserts one at a time, and the other one doing 10 inserts as a batch. And you can basically see that we get kind of 10x the performance, right? Because we're not having to do those continual network round trips in order to do that. So there are some big benefits, and if you are, say, inserting something where you can afford to lose a few seconds, this is a good approach. It's probably not good if you're handling payment data or something that you absolutely need to keep. You need full ACID properties, but you can kind of turn that dial up and down within your data access layer. So the kind of workload tuning options that we have then is really to look at, improving density, leveraging a kind of asynchronous approach as well. So, basically introduce batching and then basically buffer across time a number of insertions.
And like Ewan said, we'll talk a bit more about this at 11:45, you said?
Yeah, 11:45, yeah.
But basically everything we talk about here with regards to optimizing and telemetry and whatnot, and that we're going to go into a bit more specifics at 11:45, you should anyway do today on SQL Server, right? So it's not like, let's wait until we go into Azure until someone tells me to reduce COGS. You should start doing this today to make your app more efficient, right? Independently of if you're running in Azure or some other cloud provider.
So we're basically almost out of time. I just want to show you one or two more slides that really encapsulate some of the reasons. If it comes back, did it come back?
Not yet.
Is it coming?
There
Okay, wow, it came, great. This is EasyJet's seat selection system. So basically they came to us, they have a 70-30 read-write split, and that's because people need to go and check whether the seat is available, then they find the perfect seat, and it's kind of like a science, right? Some people get really obsessive about which seat they have on the aeroplane, right? And they kind of look on different aeroplane routes and they figure out, oh, this is the best seat that I can get.
Is there something wrong with that?
What's that, sorry? Are you...
Yes.
Right.
Yeah, I like 64K.
Okay, so you get some people who just go and pick the first available one, right? So there's this 70-30 read-write split. They have a really efficient workload. These guys spend a lot of time...
So what's the y-axis?
Oh yeah, the y-axis is the response time, basically, and the x-axis is the time here. And basically, the key thing that we're measuring here is what was their latency for the users looking at the seats over time. And basically, you can see here we did this switch. So we have switched them from the standard pool, shared pool, to a P2 offering at this point. And basically, you can see that the response time, we removed that kind of sawtooth profile. And we kept that kind of consistent response time even when they went through their kind of January flight sale. And what we found is that this kind of reduced the impact of various throttling errors. And you can see here, this is their major ticket sale. So their latency spikes that they had, even as throughput increased, were well within the kind of acceptable 200 milliseconds. And this issue here that they see was actually down to a broken build. They had an issue, within their application that caused them to effectively...
It wasn't our build that was...
It wasn't our build. No, it was their build. So that's one where we want to move to premium in order to give us a more predictable performance for our users and give them that same consistent experience as we increase throughput, right? And you can obviously scale up and scale down after you get through that flight sale. Another kind of reason we moved a customer was basically for availability reasons. So basically, this customer application is not as well written. They have a growing trend in CPU usage, and there is some optimizations that they can go there, so that they can do. And you can see the kind of spikes that they have. This is their kind of CPU. This graph here is the kind of CPU spikes that they have over time, and this is their total minutes of unavailability. And basically what they're doing, what's happening at these various points is they're crossing some of those thresholds in the standard pool. And at that point, we go on Tobias essentially goes and stops those guys, from, being busy neighbors to other people. So by actually defining that, hey, we want to have 2 CPU cores and paying for that level of reservation, it reduces their unavailability essentially because they have that level of resources dedicated. So this customer has made that decision that they're not going to tune the app right now. They're going to pay for that premium level of performance of resources in order to improve their kind of performance. But it's really important as well, not just to think about it from a database perspective. This is an example from this basically is over time the number of CPU cores that are used in an hour, and you can see the maximum that we have is 0.14 and the minimum is 0.02. And basically this was from the Florida State election system, basically reporting results for the US presidential election. Basically this is a very read heavy system, and you can see that actually by moving that system into, moving the reads into cache, even during that massive spike, they were still not using more than 0.14 cores. So it's important to think, kind of outside of the database technology and think about if I have a read-heavy scenario, caching is another option.
And they didn't have to recount the votes in the election. Yeah. All because of Azure. Very good.
All because of us. Cool. All right. So thank you very much for coming, guys. The summary is really Premium DB gives you the options to kind of dial up and dial down. A lot of the things that you did on premise are also relevant. And yeah, me and Tobias will be here at 11:45 as well for another session, and we'll be here for any questions that you have. And we'd like to thank you guys very much for coming, and enjoy the rest of your day.
Thank you.